Hello everyone, welcome to the CAD tutorial section of this presentation. In this presentation, you will learn how to CAD using Fusion 360. It is also important to note here that even though at the end of the presentation you may know how to CAD, there's still a long way to go in learning how to design, especially for our application of FTC robotics. In this presentation, we will learn how to CAD a pixel, as we have done all the previous years. First, when you load into Fusion 360, you are met with this screen. If you are met with another screen, perhaps because you are creating a new design, make sure to select hybrid design, because that is what we are doing, or we are starting with in this presentation. You can change all these settings. Here, usually we go with millimeters and grams, and we can choose what type of design this is. You have assembly, part, and hybrid. In this case, we will select hybrid for purposes that would be obvious later. Hybrid design basically combines component and part design, as is intuitive, and it is more useful usually because part design and assembly design puts more restrictions on what you can and cannot do. For example, in part design you cannot assemble objects, while in assembly designs you cannot create new parts. So let us begin. First, when you load in, you see this screen, but that's not very helpful. You have to be able to move, right? So the default keybinds for panning is the middle scroll wheel. And because of this, I recommend you all to get a 3-button mouse at least. And to zoom, of course, is scroll out and scroll in. And orbit is if you press shift and the middle scroll button that will rotate along the center. But in this presentation, I will be using black magic to navigate. So that's what you'll be seeing here. So to begin any design, we have to make a 2D object and then extrude it to a 3D object. First, we will make a sketch, which is a 2D object, right? So we press the create sketch button, of course, and we select one of the planes to make the sketch on. We will see later that we can construct our own planes by using this construct button, but that would be a thing we will get to later. First, let us select any one of these planes will work. Let's say, I think this is the XZ plane. No, the YZ plane. Sure. So we have to have a reference design only for this project. Usually we just kind of freeform and design whatever we have and create whatever geometries we need because we are creating a functional part. But in this case, we are trying to create an aesthetic part. So we need a reference picture. I downloaded a picture of this pixel here, so we will place it, let's say here. Okay, that works. First, we have to think about how we're going to make this design. First, my strategy is going to be to make half of the pixel. Mainly, we're going to begin with the body, making the red rectangle here, and also the face, and then we will create the arms and also the legs in a separate file, so that we can demonstrate linking it back to this original file. It seems that Canvas actually overrides my sketch, but I guess. So I will make a new sketch. of course, it is very easy to see how we make a rectangle. First, you just press this 2-point rectangle button here, and then you just draw. Let's say I will draw the entire pixel first and split it in half, just because it seems that my file is off center, unfortunately. That's no biggie. And then to make sure that it's a square, we can place constraints on it. These constraints, of course, constrain the geometry. So to make a square, we only need to guarantee that 2 sides are equal, like so. And of course, you can still make it larger and smaller, because the only constraint is that these 2 sides must be equal. To put additional constraints on it, we can press the dimension button to make sure that these two are as wide as we want them. So let's say 9.3 is a good place to be. But in fact, we should probably have it closer to what we actually want it to be in real life. But that would be inconvenient since our canvas is so small right now. And we will show how to scale it up later. But usually it is best practice to just start with whatever size you're trying to make. Next, let us make the eyes. So it is not very hard. You just kind of draw, you just kind of follow the sketch like so. And usually, like, the green points are the auto constraints, and usually they're pretty good. Like that looks pretty good. And same with this portion. You can go here. And what I'll do right now is actually I'll create a arc, because obviously we want to be able to make round objects. So we can make an arc from, actually no, this is incorrect. We should place a point that represents the midline. And to do this, we press the line button, and you can see, like, when I mouse over the middle point, it kind of gets stuck and shows this triangle symbol. That means you've reached a midpoint, and it auto constrains to be a midpoint. And so we can first remove, actually no, let's just leave the other side. We don't really care about that one. And notice the right palette you have here. You can either turn it into a construction line, which means that after you leave the sketch environment, it won't show up. So that means it's only useful for constraining, which is useful because obviously if you want to extrude, you don't want to select like every single sketch that is on here. So you want to designate that some of the geometry shouldn't be included in the extrude environment, or like the main design environment. Excuse me. So you have to designate a construction line. But obviously right here, we're trying to use this line as a midline, and we are in fact using it to extrude as well. So let's just designate this as a center line, because that's what it is. And we can designate these as sketches as well, construction lines as well. And now we can see that only this face can be extruded and not this face. Like, we can't select anything over here, which would be good in design clarity. And now we will continue with what we were doing. So we can create a center point arc here, which creates an arc around the center, like so. And now you see that the pixel is actually not designed very well. It's like, it is not circular, but it is okay. We will go along with it. So now, to make it like not just one line, we press the, I think it's here, offset, yes, offset, and we can offset it, let's say 0.5 millimeter, like so. And now we just connect this over to our starting point, and also this to our beginning of our arc. And to make this little bit, let's just say it goes around like here. Okay. Now we can modify this a little bit so that it's easier. Where is my sketch? So you can trim this part since it's not needed, since it's connected. And also this part, just so it's easier to extrude. And now we should be good to go. And of course you press finish sketch. And now we can hide this canvas. We don't need it anymore. So we can extrude this sketch. Let's say this way. That looks pretty reasonable to me. It's actually not supposed to be a square, I presume, because if it was a square, it would look very strange. Let's say we had so our sketch was 9.3 by 9.3. So 9.3 divided by 2. 9.3. Yeah, that looks very strange. So let's go with like negative 9.3 divided by 2. That seems reasonable to me. Okay, but you will notice because of our sketches, it looks kind of strange. So you may ask, why did we make the sketch all together? It's actually more useful just because we like to have the least number of sketches so that the dependencies are not too hard to manage. And it seems like I missed a spot here. Let's see. We can extrude this as well. And now, let's say we designate this as the front face instead. So we can make this sketch visible again, and we extrude this all the way to, let's extrude these two, let's say all the way to here. Okay, so now we have a face of the pixel, right? And of course, I will demonstrate how and why we are gonna create different components for the mouth and the eye. So first, we can just extrude this up to here, but that's not very useful, right? We just create those sketches for no reason. So instead of joining the body from the sketch, we can actually create a new component. A new component will designate that it's actually separate from this entire thing. Well, you could make a new body. That would not be preferable because you cannot join two bodies together, right? So we can create a new component. And likewise here, we can create a new component. And with this body, we will not create a new component because we will have to reflect it later. Well, that's true. I shouldn't make this component quite yet. Actually, no, I'll just leave that for now. It's okay. So now we will try to make the arms of the pixel, let's say. So first, notice that I'm sure you want the pixel's arms to be in the middle here instead of being at the end, because that would look really wonky. And to do that, we have to define a custom plane to start the sketch at. So first we will construct a midplane, which creates a construction plane at the midpoint between two faces or planes. So we can make a plane in the middle of these two faces. So now you can see that there is a face here. We can extend this, but that's not really necessary. And now, of course, we create a new sketch and take our reference picture. And it seems that our pixel is around, let's say, here. What I did just now was just create a circle. It's not too hard. And then, of course, we draw a line from this point to, let's say here. That seems pretty reasonable. And we offset this. Sorry, I'm just trying to use like more of the buttons since I usually use hotkeys. But if we offset it to around here, that seems pretty reasonable. So instead of just doing one side, let's make it symmetric. And that looks pretty good. And now we just, now we're finished with the sketch, right? So we can try to extrude it. But notice how the extrude button always makes a rectangle. But that's not really what we want, is it? So instead of doing that, we are going to make a profile that is half of these geometries, and we will revolve it around the center axis, right? That will make a circle, surely. So now we just connect this point to the, no, that is not what we want. We want to connect this point to the end here. And notice that there's a collinear constraint. That means these two must be in the same line. And likewise, we will also connect this. And you can see, sorry. Okay, that was brownie. So we can also see here that highlighted blue here are the regions that can be extruded or revoluted, I guess, on. So it's very clear that our sketch is good. So let's press finish sketch. And now we will revolve it around this axis. So we will revolve this profile around this axis. The CAD is very intuitive. So we make a new component as we do. But notice, like, right now it is sticking into the body of the pixel, which is actually what we want, right? Which will become obvious later when we discuss fabrication. So that is good for now. Let's leave it at that. Now we just have to create the legs, right? So we have the plane from before. It's under construction. We make it visible again. And now we make a new sketch that is, let's say, half the leg. So how do we do this? We can create a circle first, let's say, and that encompasses the leg. You can see again that the drawing is not very good, but we will make do. So let's try to line it up. Let's say this is good enough. And as we have done before, we just make a line from here to the body. Let's say it goes into the body a bit, around here, and connects to the edge here. And also we can offset this profile to be around here. That seems reasonable to me. It is also important to note that usually with functional designs, we cannot just draw freehand. We usually need to set these dimensions because we need them to be exact. But right now, that is not that big of an issue. So now we finish the sketch and of course revolve it around the center axis. Like so. And of course we create a new component. And we're basically very close to being done. We have half of the pixel. And we have the arms and the legs. However, as we have noted before, this is not really the size we want. Let's see. We can inspect the size of this pixel by pressing the measure button, which measures the distance between two faces. If you press the measure button and select the bottom foot and also the top, we can see that it's around 12 or 13 millimeters. My pixel that I printed is, let's see this. It's around 9 centimeters. So we can scale this up so that it matches the real world size. To do this, we modify and we scale, of course. And we select all of these bodies. You can also select them here, I believe. Seems like I can't, but this works. And around, I guess, any point, that point works. And we can select it to be, what's the conversion factor between 12 millimeters and 9 centimeters? You have like, let's just say like 9 over 12 times 10. Is that right? Let's measure it again. My math isn't really mathing right now. Centimeters. 9.6 centimeters. That works. No, that's good enough. So now we just simply mirror it to the other side. Like so. We can mirror this over to the other side. That's not an issue. We should probably create a body here. And we can also create the other arm using the same plane. That looks good. But notice what we said before about this body. This body is not actually complete, right? Because how are you going to make this IRL? You can't, because the limitations of 3D printing actually restrict you from designing geometry like this. In that sense, this design is incomplete. First, we have to create holes for the arms and legs. Why, you may ask? Usually, it is very naive to print everything in one piece, because notice here that we want the body to be red, but the arms to be black. How are you going to do that? Right? You can't. And secondly, this is very hard to print, since what orientation are you going to print it in? You can either print it on the back, but notice what we have here, right? If you lay it on its back, then this joint will be very weak because it goes against the grain, or like the extrusion path of the print head. And also you have to have like a ton of material down here. If you can see where my mouse is, like you have to have all this material down here, and also this will look very ugly. But if you print it upright, notice that you will also have a lot of support here, which is a pain to remove. Likewise, if you have it on the top, then you'll have a lot of support here, and this arm would be very ugly. So it is very naive to try to print it all in one piece. And this is why we want to create many components so that we can print, for example, these two together, and then print the main body, and also maybe print the face, the eyebrows, I don't know what you call them, with all the other black pieces. So now we have to modify this body so that we can actually fabricate it. So to do this, we have to create holes for the legs, of course. And so let's just first do that. We can reference the other component by pressing create project, and that actually, as the name implies, projects the geometry onto the plane you're at. And this is very useful because you don't want to, like, if you didn't have this tool, then you would have to go here and try to match the size of the leg, which is very tedious, and I'm a very lazy person, so I don't want to do that. And now we have the leg geometry here, but if we create the hole right now, that also won't be fabricatable, because as you know, doing 3D printing, the holes get smaller and the outside geometry gets bigger just because of heat expansion. So we will apply the standard 3D printing offset of 0.1 millimeters, or at least that's the offset for my 3D printer. So we offset this by 0.1, and we mark this as a construction geometry because we don't really need to extrude that. And so we can finish the sketch and extrude. No, we can, to access the inside here, we can hide this component and extrude all the way, let's say here. Let's see if that's accurate. You can reference here, you can reference this leg over here, it goes to about here. It's overkill, so we can lower it maybe like here. Here is good because you want to, again, leave some space so that the effects of heat expansion are countered. So we can finish that. And now we should, actually no, on accident I actually extruded and cut the leg. So we can edit this feature. And the usefulness of Fusion 360 is also demonstrated in the fact that you can just go back. I will show that right after I do this. So to not cut like other bodies, you just select objects to cut, and you can see that this is body 1, and if it doesn't have a component at the end, let's say I can expand this. If it doesn't have a component at the end, it means that it's part of the main component. And notice that it has component 4 here, and that's one of our legs here. So we can unselect that. Now the leg won't be cut, and we can finish editing this. And so you can see that everything is well and good. It is also interesting to note that you can rename these components. So we can name this like smile, and this one's eye. This one is gonna be arms. This one's gonna be legs. And we will now also do the holes for everything else. But it is also, but you may wonder, like, how are we going to create the hole in this place, because the the geometry is kind of wonky. So first, I feel like the most efficient way is to first extrude it based on this geometry here, and then add our standard offset. I don't know why my dog is so barky today, but we will proceed. So first, let us hide this body so that we can access this geometry here. And we extrude from this face so that it cuts through this body. Yeah, so we just cut through here. We can actually go right like over here to be safe, because we can always deselect, of course, the arm body. So that's good. So now we have a hole, right? We can hide the arms, but this is, of course, not fabricatable. To expand the hole, we can use press pull, which makes the geometry bigger or smaller. So we can make it, let's say, negative 0.1. So 0.1 millimeters bigger. Okay, that should be right. Yeah, see, now we have an offset of 0.1 millimeters. Press pull is very useful for, like, you can see the tutorial here by expanding the holes. But we can also just do an offset sketch for linear geometry, but for circular geometry, press pull is actually really useful. And now we can also create the offset for the smile here. And I think the easiest way to do this is to just create a new sketch here and offset this by 0.1, negative 0.1. And I think this should be good. For safety, we should probably also offset this middle part, but it seems like Fusion won't let me do that. So now we have to close this so that, you know, it's highlighted with blue, so that you can actually extrude it. That looks good. So now you are able to extrude from this sketch. Now we press finish sketch and extrude this all the way down to the end here. And to make it precise, we can simply hide this component, and we just press this face and it'll automatically snap to that face. It's barely noticeable, but that should actually help a lot in 3D printing. And of course, we do the same here. We can create a new sketch and also offset this. I'm pressing O, which is, I'm pretty sure, the standard offset for the standard keybind for offsetting. And we're applying 0.1 millimeters again, and we can offset. We can extrude this using the same method as before. You can see that actually I can't select it because the or can I? Yeah, I can't select it because the sketch is in the way. So we can actually just hide the sketch, I'm pretty sure. Yeah, see, now it will extrude and snap to the correct place. Okay. Now there's a hole, and this should fit. That looks good to me. So now everything is set, and we can we can mirror this over to the other side. Okay. Let's just create a new body. It is also very important to note that pressing the join operation is very dangerous because that's highly interpretable, right? Are you going to join to this, or are you going to join to this, or are you going to join to this? So usually we like to join them manually. So let's create a new body. And of course, we should also mirror these to the other side. I don't seem to be able to access any of the planes, so we can hide this body and mirror it over here. That looks good. So now basically we're very close to being done. First, we should find it prudent to combine these bodies because it is in fact going to be one. So to do this, we just press the combine button and combine these two. And we should also create a new component. So this is, I think it's one of the glitches of Fusion that actually creates a residual body, but that's no biggie. We can just hide this. We sweep it under the rug as we do. And likewise for these two pieces, we don't make a new component because it's already in a component. And likewise, actually no, the eyes are good. But notice what we have here. Well. The legs seem to be touching. That's not good. So we can scroll back to where we created the leg. Let's say here. Right, leg was created here. So the sketch for the leg is here. We can edit the sketch and make it just a bit smaller. We can make it like this, let's say. And if we press finish sketch, it'll recompute all the geometry. So if we scroll up all the way to the end, it's not touching anymore. See? That's very useful because you can just simply go back in time and edit anything that you would like to, which is one of the best things about Fusion. But now, this is not very aesthetically pleasing. We can modify this to be more aesthetically pleasing because oftentimes people evaluate your design based on how pretty it looks, and usually we want to make it look very pretty. So fillet, I think it's pronounced that way, makes all of your corners round, while chamfer makes all of your corners straight. We can demonstrate this by doing something like this, but we can also demonstrate the chamfer by doing something like this. Right? I feel like fillet looks better on this design, but oftentimes you will find that the chamfer is also very useful, especially for top corners, because your 3D printer really wouldn't like fillets. But for now, I think it is okay. I printed mine with fillets, but they don't look that good just because the layer lines don't really align. But that is an exercise for another time. So now that we've selected all of our edges, we can just visually confirm that that looks good. That looks pretty good. Hold on. Okay, I'll keep it like this. It's a bit round. We can also assign colors, of course, by, how do we do this actually? Appearance, yes. I usually just press the hotkey, so. you're taken to this this pop-up. So you can simply select like red. This is my favorite red actually, so I will apply it to the body by just simply dragging the color over here. And I also have a favorite black, which will be applied in the same manner. You can also apply it to like these. You can also drag it to over here to apply it quicker. That works. And let's rename this to body. And now this design looks pretty much complete. But, right, huge issue. Let's say we want to move this design because we are in another design. Let's see what happens. Okay, that doesn't seem good. So, to remedy this situation, let's define this geometry more explicitly. So, let's say we move the legs. Let's say we move the legs down, right? How do we prevent it from going down like this? We assemble. You can see that there are many options here. Usually we want to use a joint, as-built joint, and a rigid group. It is also very tempting to press the constrain components button, but this is usually never useful. You want to define this more explicitly. So you press the joint button, and usually a simple joint is good enough, but I think there is an option to more explicitly define it using faces, but usually we just go with the center here to the center in the hole. Like so. And you can see now that if I try to move this, everything comes along with it. But notice how it kind of snapped to the bottom. That's also a plus in the design, I guess, in joining your components, because you can see which components have predominance over the others. But actually, let's go to the one before, because there's actually a simpler way to do this. As I have mentioned before, you can also use an as-built joint. So an as-built joint it basically defines the joint based on where it is right now. So we can do an as-built joint from here to here. But we can also make a rigid group like so. And a rigid group is basically an as-built joint but for many objects. As-built joints are usually preferred because you can define them to be non-rigid. For example, you could make this one spin. Like if we go back to this one, edit joint, you can make it like revolute or a slider or cylindrical or pin slot, but with the rigid group you can't. So that's the difference. And now it seems that we are done with our pixel because we have created every single component, and we have also made sure that it is fabricatable. Thank you for listening to this tutorial, and if you have any questions, feel free to reach out to me on Pronto or on Slack. Thank you.